Heptyl. Even the name sounds ominous. It conjures images of shadowy figures and hidden dangers lurking just out of sight. It hints at something hidden, something powerful, something potentially dangerous. A substance that holds secrets within its molecular structure waiting to be unleashed. And that's exactly what Heptyl is. A potent fuel that has propelled humanity's ambitions into the cosmos, yet remains largely unknown to the public. This colorless liquid, scientifically known as Heptyl rocket fuel, is not something you'd find on the shelf of your local hardware store. It's a specialized substance reserved for the most advanced aerospace applications. It lurks in the shadows, a critical component in some of the world's most powerful rockets. Engineers and scientists handle it with the utmost care, aware of its volatile nature. But its power comes at a price. The very characteristics that make Heptyl an effective rocket fuel also make it hazardous. Heptyl is a substance of contradictions. It is a marvel of chemical engineering, yet it poses significant environmental and health risks. It's essential for space exploration, yet it poses significant risks to human health and the environment. The duality of Heptyl is a stark reminder of the delicate balance between progress and preservation. Understanding Heptyl, its properties, its history, and its potential impact is crucial in our technologically advanced world. As we push the boundaries of what is possible, we must also consider the consequences. Join me as we delve into the fascinating and concerning world of this enigmatic substance. Together, we'll uncover the mysteries of Heptyl and explore its role in shaping our future. Why is Heptyl considered so dangerous? In a word, toxicity. This substance is highly toxic to humans and other living organisms. Exposure to Heptyl can occur through inhalation, skin contact, or ingestion. The effects are far from pleasant. Short-term exposure can cause a range of symptoms from coughing and dizziness to nausea and vomiting. More serious effects, such as chemical pneumonia and lung damage, can occur with prolonged or high-level exposure. Long-term exposure to Heptyl has been linked to liver and kidney damage, nervous system disorders, and even cancer. The risks associated with Heptyl are undeniable. It's a substance that demands respect and caution. The dangers of Heptyl are not theoretical. This highly toxic substance has been at the center of numerous catastrophic events, each leaving a trail of destruction and environmental damage in its wake. From industrial accidents to space missions gone awry, the legacy of Heptyl is a grim reminder of the potential hazards associated with its use. History is littered with incidents that highlight its potential for harm. Industrial sites have been abandoned, and entire ecosystems have been disrupted due to Heptyl-related accidents. The substance's volatility and toxicity make it a formidable challenge for those who handle it, often with dire consequences. One of the most well-known incidents occurred in 1986 when the Space Shuttle Challenger exploded shortly after liftoff. The tragedy claimed the lives of 7 astronauts and left an indelible mark on space exploration history. While the explosion itself was not directly caused by Heptyl, the subsequent release of large quantities of the substance into the environment raised serious concerns about its impact. The aftermath of the Challenger disaster saw extensive cleanup efforts, with hazardous material response teams working tirelessly to mitigate the environmental contamination. The incident underscored the need for stringent safety protocols and the importance of preparedness in handling such dangerous substances. In another incident, a Russian rocket carrying Heptyl fuel exploded in 1996, scattering debris and releasing toxic fumes over a wide area. The explosion not only posed immediate dangers to human health, but also had long-term environmental repercussions. The toxic fumes released into the atmosphere contributed to air and soil pollution, affecting local communities and wildlife. These incidents, along with numerous smaller spills and leaks, serve as stark reminders of the potential consequences of mishandling this hazardous substance. Each event adds to the growing body of evidence that underscores the need for improved safety measures, better regulatory oversight, and increased awareness of the risks associated with Heptyl. The legacy of these incidents is a call to action for industries and governments alike to prioritize safety and environmental protection in their operations. To understand why Heptyl is so dangerous, we need to delve into its chemical makeup. Heptyl, also known as N-heptane, is a straight-chain alkane with the chemical formula C7H16. It's a colorless, volatile liquid with a gasoline-like odor. Its chemical properties contribute to both its usefulness as a rocket fuel and its hazardous nature. Heptyl is highly flammable, which makes it an efficient fuel but also increases the risk of fire and explosions. It's also highly volatile, meaning it evaporates easily and can quickly contaminate the air and water sources. Understanding these chemical properties is crucial for developing safe handling and storage procedures. Section 5. Handling with care safety. First, when it comes to Heptyl. Given the inherent dangers of Heptyl, stringent safety measures are absolutely essential for its handling and storage. Only trained personnel wearing appropriate protective gear should handle this substance. This includes respiratory protection to prevent inhalation, gloves and protective clothing to prevent skin contact, and eye protection to prevent splashes. Storage facilities must be specifically designed to prevent leaks and spills. Regular monitoring and inspection are crucial to ensure the integrity of storage containers and to detect any potential problems early on. Section 6. Heptyl today, current applications and concerns. Despite its dangers, Heptyl remains a vital component in certain areas, primarily as a rocket fuel. Its high energy density and relatively low freezing point make it suitable for use in liquid-fueled rockets. However, the use of Heptyl is not without controversy. Environmental groups and local communities have raised concerns about the potential impact of Heptyl releases on human health and the environment. In response to these concerns, there's a growing movement toward developing and using safer, more environmentally friendly alternatives to Heptyl. Section 7. The dilemma, weighing the risks and benefits. The use of Heptyl presents a classic dilemma, weighing the benefits against the risks. On the one hand, Heptyl has played a crucial role in space exploration and other technological advancements. On the other hand, its potential to harm human health and the environment cannot be ignored. This dilemma has fueled ongoing debates and research into finding a suitable replacement for Heptyl. It's a complex issue with no easy answers. Section 8. Looking ahead. The future of Heptyl. What does the future hold for Heptyl? While it's difficult to predict with certainty, several factors suggest that its use may decline in the coming years. Research into alternative rocket fuels is gaining momentum, driven by environmental concerns and technological advancements. These alternatives, such as methane-based fuels, offer the potential for reduced toxicity and environmental impact. Additionally, increasing regulations and public pressure are likely to push for stricter controls on the use and disposal of Heptyl. Section 9. Conclusion. Heptyl, a substance demanding respect. Heptyl is a substance of paradoxes. On one hand, it has been a cornerstone in the advancement of space exploration, enabling rockets to reach the stars and satellites to orbit our planet. On the other hand, its toxic nature poses severe environmental and health risks. This duality makes Heptyl a subject of intense scrutiny and debate. It's essential for some of humanity's greatest technological achievements, yet poses significant risks to our well-being and the health of our planet. The use of Heptyl in rocket fuel has allowed us to achieve milestones that were once thought impossible. However, the environmental toll it takes cannot be ignored. The emissions from Heptyl-based fuels contribute to air and water pollution, affecting ecosystems and human health alike. Understanding the properties, dangers, and historical context of Heptyl is crucial for making informed decisions about its use and for developing safer alternatives. Scientists and researchers are continually studying Heptyl to mitigate its negative impacts. Historical data provides valuable insights into how Heptyl has been used and the consequences of its use, guiding current and future policies. As we continue to explore the cosmos and push the boundaries of technology, it's imperative that we do so responsibly, minimizing the risks to ourselves and our planet. The quest for knowledge and advancement should not come at the expense of our environment. Engineers and scientists are now focusing on developing sustainable technologies that can replace Heptyl, ensuring that our progress does not harm the planet. Heptyl serves as a potent reminder that progress must be balanced with caution and a deep respect for the power of the substances we harness. As we look towards a future of endless possibilities, let us remember the lessons learned from Heptyl. By respecting the power of such substances and striving for safer alternatives, we can achieve a harmonious balance between technological advancement and environmental stewardship.